So now that we've had that quick aside, was one of the questions that came up. We'll go back to this question about the bang object within the FM thing. So first, let's look at what's coming into the first level of this abstraction. So we have values coming from the counter, we have frequency values in the second inlet, and then in the third inlet, again, we have values from the counter. The values from the counter on the third inlet are controlling the preset object that I made for this filter graph object, essentially. The values that are coming in from the counter into the FM thing are going into the second inlet. So this is counter elements, and it's controlling the presets of that we've made for the different colors or timbres that we want from the FM synthesis, both the envelopes and the harmonicity, for instance. And then it's also sending a bang every time. So not a load bang, but a bang every time it gets an input. So no matter whether this counter says that we're on the first, the second, the third, the fourth, the fifth step, every time it gets an input of any kind, it's sending a bang. And the question is, why is it sending that bang? Why do we need that bang? And the answer is because it has to do with the function object here. Basically, when we set these different, when we choose a different preset, it is changing what's going on over here in the function, among other things. So it's changing our envelope, the envelope of our sound. But it's changing it with this message set domain. So when it's changing it, it's not actually outputting this value at all. It's just setting it up so that when it gets a bang, it can go. So, I'm changing these values, nothing's happening. If I hit that bang, now you can see from this value coming from the line object, we're actually getting the envelope coming out of the function objects to the line to this number object, which it doesn't actually do anything besides, I just put it there in order to demonstrate the values that are coming out of the line object, so I don't actually need that. So that's what the bang object is doing in here. There was a question about this preset object and whether there's a way to make it store only one, the value for one object. And I've shown you how to exclude one object from storing the values. But if you had lots of different values that you were trying to, and you wanted a different preset to control each one of them, then what you would want to do is have a bunch of different preset objects and use this outlet, which says connect to objects to include in a preset. So the default is if it's not connected to anything, then it's selecting everything. But if you were to connect just one object here, then it's going to exclude all of the other objects and only include the values from this single object. So just to demonstrate really quickly, I'll say go shift and store here, and then I'm doing this other one that's not attached, shift and store here. So this, when I click here, it goes to 35. When I click here, it goes to 89. But notice that this value that I was changing in the for the filter graph is not changing at all, just including this one value. So that's how you include only one. That's how you have a preset control only one object. And if you're ever not sure about these things, again, the way to check, the first thing to do is just to hover your mouse over the inlets and outlets when the patch is unlocked. And the second thing to do is to read the documentation, because the answers are all there. That's how you learn a new language, is essentially by finding new objects and reading the documentation and trying to figure out what's going on. There's a question about what's going on with the sound. So what's happening right now is you're essentially you've got these two FM subpatches, and you're listening to both of them at the same time through a filter. So you're essentially combining them in essence as if it's additive synthesis, because you're listening to both of these sounds at the same time, the same way we're doing with the poly object in the additive synthesis example. Now, you could also, theoretically, combine these in different ways. You could use the signal of this object to control the frequency, for instance, of this object. And the way to figure out how to do this is to look at the original files. Okay, so what's going on here is you have your carrier oscillator here, right? So that's your essentially your main signal, and this is the frequency that you're giving to that that carrier oscillator. You're also giving your carrier frequency over here to a multiplication object, as well as what's called a harmonicity ratio. So this is essentially you're saying, okay, what is the value that I'm going to be wanting for my modulating oscillator? And the way you're finding it is not just by picking some random value or frequency. It's by using the original frequency and multiplying that by some sort of relationship. So essentially you're creating a relationship between the carrier frequency and the modulating frequency. Then you're using that to set the frequency of the cycle value over here. And you are over here controlling the amplitude of this modulating oscillator. So you have frequency, you're sending it out, and then you're using this other object over here to control how loud this signal is. And then, so you're using this signal over here to modulate your carrier oscillator. So if you wanted to control one of your so if you wanted to use the signal from your FM subpatch here as a modulator signal for this, and have this be the carrier signal, you would essentially work through the problem and try to figure out, okay, if this is the modulating signal, how do I need to put this together in order to create a modulating signal that's from my modulated signal, if that makes any sense. So yes, there are ways to combine these things, and I encourage you to try to work through that problem.